Our plant experienced an unusual problem with some superheated steam coils in a fluidized bed reactor. We manufacture chemicals, but one of our most important byproducts is superheated steam. It is probably our second most important product in terms of profitability. When one of these coils leak, the properties of the fluidized bed no longer are controllable, and it's just a bad day all around. These coils were becoming plugged and developing leaks. And the plant manager asked me, we need to measure these flows. I need to be able to explain to management or forewarn management of impending issues that might cause us to be down again. A forced outage would have meant millions of dollars in lost production. When we're not running, we're not making money. I sent an email to my specialists and I said, guys, I need a miracle flow measurement, because I've got these superheated steam pipes that have no process penetrations. There's no flanges. It's completely welded. It's very hot. What do you have that can help us figure out what's going on inside? The suggestion was, why don't you try the 708 wireless acoustic transmitter. It's designed for listening to things like steam traps and safety valves. And fortunately, the steam going into our fluidized bed reactor was just below the maximum temperature rating of the 708s. However, the steam going out was too hot, so we had to, in those cases, we just used the 248 wireless temperature transmitter. And we got enough of those to connect, to attach to all the coils, and away we went. We wanted to be able to know, could we make it to a planned outage without an unplanned outage, if you will. And we wanted to be able to have the flexibility to take that outage when we were ready. The wireless heart gateway and probably about 70% of the devices started showing up within a week. Pretty much as soon as they hit the ground, we were able to start configuring them. We cut the purchase order on June 23rd, and before the 4th of July holiday, I would say a good 80% of the points were online and functioning. So that's what I call rapid deployment. Being wireless definitely helped with getting those measurements online in a hurry and getting us the information, some of the information and some insight into what was going on very rapidly. We were able to detect, largely through the temperatures, that some of the coils were indeed had very little, if any, flow. It also allowed us to delay that outage until we had all of those forces assembled, all the crafts and the other infrastructure necessary to perform the chemical cleaning and do some of the welding and whatnot that also had to be done. So being able to plan an outage and be organized for it probably saved us millions of dollars.